Okay guys, in this video I'm going to give you a real quick review of what we talked about with the SI system historical information. Remember the second? Okay, so key pieces of seconds are the original definition was about our solar day, and the new and current definition now relates back to the radiation of cesium-133, or basically how fast that isotope radiates. Keep in mind that all of these definitions, we have a historical side to them, and then the new development is always based off of something that is consistent and will never change as far as we know. And that's the idea, is to find some sort of way to base our time, our distance, our lengths, all off of things that would never be changing for us, okay? The kilogram is actually the only mass the only thing that we still have a physical object with, which is kind of an issue. It is a platinum iridium, basically sphere that's housed in France. That is our standard kilogram, but there is work ongoing that's trying to find a way to eliminate this as our standard and find something that is universal, that cannot be affected by natural disasters or corrosion over time. The meter used to be a distance basically from the North Pole to the equator. Now it is defined as basically how fast the speed of light moves in a certain amount of time. Okay, so this kind of gives you that definition, but now we're basically talking about, well, how far would light move in X amount of seconds is basically what we're talking about for meter now. Again, keeps that standard very consistent. Make one note, remember 1 meter does not equal 1 yard. Okay, things that are a meter. Okay, so here's some examples of that. This is probably more like 2 meters, I'd say. Kitchen countertop is probably your best comparison there. You walk up to your countertop, that's almost perfectly a meter every time. What's a liter? Okay, liter isn't actually a base unit. It's derived from cubic stuff. So if you take a look, most of this information here is going to be talking about how it's based off of a cubic decimeter, or how you're cubing lengths to actually get to a liter. Okay. Everyday items that are grams. So 1 gram, this stuff looks really good. Let's not talk about a piece of gum. We said that was actually probably too heavy. The dollar bill is probably your best bet. That is actually minted to be, or printed, sorry, to be exactly 1 gram. Okay, so it's kind of a really good comparison here. 20 Tic Tacs would be 10 grams, and so forth. Kelvins. Don't forget about kelvins. Kelvins are a temperature scale we need to be based off of absolute zero. Also remember how to convert between Kelvin and Celsius. So Celsius plus 273 would give you your Kelvin scale. It is needed because when we do mathematical equations with temperature, we need to work in kelvins because it's an absolute scale, because it actually relates directly back to energy here. Here's 3 examples of the scale that they put in here, which look really good. So it shows you how you can convert between those. So 0 Celsius is 273 kelvins, and so forth. A mole. We'll talk more about moles later on, but a mole essentially is a way for us to count atoms by measuring mass. Okay, so it's a quantity or an amount of something, and it has this gigantic number of 6.022 times 10 to the 23rd power. Okay, so this should be a 23rd raised to an exponent there on that one. And it basically gives us this relationship between atoms and the mass of our atoms. Everyday items that are kilograms. Okay, liter pop, hair dryer, cantaloupe. Those are all really good things. Baby lion. I'm not really sure if we know what a baby lion is, but hey, a duck, 2 kilograms. All good ones to compare. Everyday items that are milligrams. Okay, milligrams are so tiny, it's really hard. So a postage stamp is actually 20 of them. A grain of salt, a third of a grain of rice. So we're talking tiny, 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 tiny amounts of mass if we're doing milligrams. Okay, we do a lot of antibiotics and medications in milligrams. Keep in mind that that's the medication in the pill, not the total mass of the pill itself. The pill itself probably has much more mass because it has fillers and other things to help bind everything together there. Meters we've already talked about. I'm not sure if dinosaurs helps us out a ton, but 10 meters for a bus, that's pretty good. Height of countertops, again, I'd use that probably as my base one. 2 meters, NBA type basketball players, 6'6" is 2 meters, so it kind of gives you an idea of what 2 meters is there. Millimeters. I like using the penny thickness as being one that gives you a really good comparison, or a marble and those kind of things being about 10 millimeters are pretty good for that one. Kilometers, the comparison of like a 5K or a 10K race is really good. The comparison of walking from Egan High School to Cub, it being a kilometer, I think we all kind of can see that pretty well. So those are pretty good comparisons there for a kilometer. And then liters, I think liters are pretty easy for us. We know because we know about a 2 liter bottle and some other liter things. So those are definitely things that we can use to compare liters. Milliliters, again, is a very tiny amount of measurement, but having a hockey puck, a gumball being 10, a couple ice cubes being 10, those are all good examples there. All right, guys, so that is everything. It was very quick, but you can go back through this yourself in more detail as you prepare for our exam on this. Thank you.